Hi again, and welcome to our 87th test and measurement video. Today we'll see how a Tektronix MDO3104 series oscilloscope can display a CAN bus serial signal. The source for the signal is a Tektronix Demo One board, which has terminals to which analog oscilloscope probes equipped with hook tips can be attached. The terminals output a number of serial bus and other types of signals. The Demo One board is USB powered from the oscilloscope. It is essential to use the specialized dual USB cord. It has two Type A connectors that must be plugged into separate USB slots in the oscilloscope. To access a CAN bus signal in the Demo One board, we connect two TPP probes to CAN bus L and CAN bus H terminals, and we clip the ground return leads to nearby ground terminals. If the signals that appear in the oscilloscope display are quite blurry, they can be cleaned up by performing a signal averaging operation. This is done quite simply by pressing acquire, then mode, and average. By averaging multiple waveforms, the successive images are superimposed and reinforce one another, while noise, which is random, cancels out. This works only, of course, when the waveforms are repetitive. The number of waveforms to be averaged ranges from 2 to 512, set by multipurpose knob A. Here's what the signal looks like when the number of waveforms is set at the maximum. As you can see, the L and H signals for this CAN bus comprise a differential pair. H swings high when L swings low, and H swings low when L swings high. This suggests a very easy troubleshooting strategy. Just compare the two signals in the two oscilloscope channels. If they are not opposite polarity mirror images, they are not functioning as intended. You can switch connectors at both ends to find out if it is a line problem. CAN bus stands for Controller Area Bus. It was introduced by Bosch in 1983 and quickly spread throughout the automotive industry worldwide, and subsequently was used in elevators and all sorts of industrial applications. CAN bus signals are received uniformly by all nodes, unless they are designed to filter them out. One variant, high-speed CAN, is the two-wire balanced signal design, which is shown here. Thanks to common mode rejection, there is a high degree of noise immunity and fault tolerance, which is why CAN bus is successful in electrically noisy and environmentally challenging automotive and industrial applications. High-speed CAN bus lines are terminated with 120 ohm resistors in order to match the characteristic impedance at both ends. This prevents signal reflections, data collisions, and information loss. When passively biased, the two signal lines measure 2.5 volts, which increases to 3.5 volts when the CAN H line becomes dominant. Simultaneously, CAN L drops to 1.2 volts, so that there is a fluctuating approximately 2 volt differential signal. Thanks for watching. New videos are added periodically, so check back frequently.